Hi everyone, I'm Shichang Xi from University of Michigan. Today I will talk about Mobilizer, a mobile network measurement platform. So this is a joint work with Esther Nikravich, Hong Yiyao, and Professor David Chofnis, and my advisor Molly Mao. Mobile apps are increasingly popular these days, and cellular data traffic has increasing tremendously. Despite their enormous success in delivering the internet, accessibility, performance, and reliability problems are still common. When such problems occur, users get frustrated, and we want to understand the root cause and fix them as soon as possible. However, it turns out try to diagnose the root cause of performance problem is quite challenging, largely due to the fact that we have little visibility into the network. For example, when YouTube hangs, there are a wide variety of potential reasons. It may be due to a slow device, or a weak signal strength, or contention for bandwidth. And to understand the root cause, we need to do extensive network measurement. We are not the first one to observe this. For example, there are a wide variety of apps that measure network performance. However, we think they suffer from three key limitations. First, they do not scale. Each of them only covers a limited number of users, which is not necessarily enough to get a wide coverage. And second, even if the app collectively have a large number of users, it is very hard to merge the data sets collected by different apps because the data format is different and the measurement methodology is not unified. For example, context information such as signal strength collected for each measurement is inconsistent, even if collected at all. And the third, these solutions are not coordinated. So for example, different apps can measure the same property on the same device, wasting a lot of valuable resources on the mobile device. What's worse, the measurements on the same device at the same time can interfere with each other. So instead of proliferating apps that conduct independent network measurement, we propose using a standard library that apps include in their code. So towards this goal, we developed Mobilizer, a unified network measurement platform in cellular environment. In this talk, we will answer these key questions related to the design of Mobilizer. What measurements do we support? How do we coordinate on a single device? How do we coordinate on multiple devices? And what new measurements do we enable? Let's start from what measurements do we support. So when deciding what kinds of measurement do we support, we face a trade-off between flexibility and safety. So allowing running arbitrary code can provide complete flexibility. However, it cannot ensure safety in that we cannot predict the resources consumed by the measurements, nor whether the measurement will terminate at all. So the alternative is to only support a small set of standard measurements, such as P, transroute, HTTP GET. And Mobilizer supports these standard primitives, as well as some complex measurements, such as web browser measurement, video streaming measurement. And to provide flexibility, it supports composing measurements by running these primitives in parallel or in sequence. So Mobilizer supports three kinds of measurement. The primitive ones, including the pin, transroute, TCP throughput, and the complex ones, including web browsing and video streaming measurement. It also supports composed measurement where multiple measurement primitives runs in sequence or in parallel. So now let's look at an example of composed measurements. So composed measurements combines multiple measurements into a single experiment, where this experiment runs in sequence or in parallel. Further, the measurement results of each sequential task can be used as a precondition of the subsequent measurement. For example, we can trigger diagnosis task in response to network anomalies. For example, we can trigger transroute probing for high-pin RTT destinations. We first do a pin measurement. And if we observe a high latency, but the signal strength is strong, then we do another transroute measurement to understand whether this is caused by a routing problem. So in this case, we only run the relatively heavyweight transroute measurement when we detect a long latency, instead of doing a transroute measurement after every pin measurement. Now we can easily build measurement apps using the library. However, the measurement done by these apps can be influenced by each other and traffic generated by other apps. And why does that matter? Let's look at an example. Here are two apps with Mobilizer running on the same device. While one is doing a transroute measurement, the other one is doing pin measurement. Here is the result of the pin measurement results. The X is the latency get by pin measurement, and the red one is pin measurement without interference, and the blue one is pin measurement with interference. And we can see there is a median difference of 1 second. Therefore, it is critically important to account for interference when measuring from mobile devices. To address this problem and to provide a measurement execution environment that enforces network measurement isolation, we introduce a single local measurement scheduler on each device. So all apps will submit the measurement task to the scheduler, and the scheduler will only execute one task at one time according to the priority. So the task with the highest priority will be executed first, and redundant measurement will be eliminated. And further, it will also monitor traffic generated by other apps and pause or kill the measurements that are subject to interference. In addition, the scheduler will account for how much data and power is consumed by the measurement and ensures that they are within the user-specified limits. When the data or energy consumption estimate of a task exceeds available resources, the task will be suspended until the constrained resources are replenished. Now let's answer the question, how do we coordinate across different devices? So the local scheduler can schedule measurements on a single device, and to coordinate between multiple devices, we design the global manager. So experimenters can can use the global manager to schedule experiments across the devices and collect anonymized data from all these devices. The manager also keeps a global view of available resources and ensures fairness between different measurement tasks. It also ensures limits that prevent harm to the network or host, like DDoS attack. With the support of Global Manager, measurement can be done in an interactive and dynamic fashion. For example, we say that a device receives a high latency, and we want to understand whether this is specific to the device or carrier or location. So let's start from testing whether this is specific to a device. So we schedule another measurement to another device with similar environment, and the result shows this device also have the same problem. So it's not specific to the device. Next, we will check whether this problem is specific to the location. So we schedule another measurement to another location with the same carrier. And it turns out this is also not specific to the location. And next, we will schedule, to say whether this is specific to carrier, we will schedule another measurement to another carrier. And there is no problem on other carriers, so we can conclude that this problem is probably carrier specific. Because Mobilizer is a distributed, controllable system, we must ensure security and privacy in our design. And we address 3 targets for the attack: the controller and the mobile devices and other hosts, like including our measurement servers. The attackers may try to subvert the control channel or the controller. To mitigate this kind of attack, we use Google App Engine as our global controller, and which relies on HTTPS to communicate with the mobile device, and use Google account authentication to give access to only to authorized users. Attackers may wish to take control of the apps by running code that compromise the app. However, we only support executing measurements that are validated, limiting the attack surface for compromise. A malicious developer could try to drain the resource on the device by scheduling a large number of measurements. This can be mitigated using hard limits, which is enforced by the local scheduler. To prevent a DDoS attack, we also account for all the measurements and put limits on how many measurements can target at a specific domain or server. Mobilizer is also designed with privacy in concern. It requires explicit consent from users, and all sensitive user information is anonymized. Also, this research is get IRB approved. So last, we want to answer what experiments are enabled. So besides those common primitive measurements, we enable new measurements, including web browser measurement and video streaming measurement. For web browser measurement, we collect we use 2 metrics to categorize the web browsing QoE: the page load time and page inactive time. Page load time means the delay to fetch all the resources for a web page, and page inactive time means the delay for the browser to first render the page. And both of them are important to categorize user experience. And we are the first to crowdsource page inactive time. Further, by combining dependency graphs generated by wprof, we can break the page load time down into computation time and network time. Here, one of the key findings of the measurement is that computation is responsible for a large fraction of page load time. This figure shows the computation time for different websites on different devices. The X is different website and the Y-axis is the computation time. And we can say that the CPU resources can be a significant bottleneck. So by doubling the CPU frequency, the computation time can be reduced by 33% to 59%, which is significant. Since Mobilizer introduces so many important functionalities, we think people have an incentive to adopt it. For researchers, they can conduct measurements on any of the devices in our system instead of devices owned by themselves. For developers, since we provide the infrastructure that supports measurements such as throughput measurement, the operational cost can be reduced significantly, and the coding and debugging effort are also reduced. And for the users, the incentive depends on the app. And for example, using the app developed by Mobilizer, they can verify carrier SLAs and compare the performance across different carriers. Since the time is limited, there are much more details in the paper. In summary, Mobilizer is a unified mobile measurement platform that provides a unified way to do measurement in cellular environment. It also provides measurement isolation and a dynamic way to schedule measurement. We sincerely hope more people will adopt Mobilizer for their measurement needs. So currently there are 3 apps using Mobilizer, and we sincerely hope that the next app comes from you. All the data is anonymized and publicly available, and thank you.
Thank you.